Hello. So today we're going to talk about multi-step equations. And these are going to be equations that take more than one step to do. We've seen before one steps and two steps. Now we got multi-steps. Speaking of steps, let's take a look at what we need to do to solve these problems. So I see that we have three things: distribute, combine like terms, and then isolate the variable. But what do those even mean? When we distribute, I'm talking about the distributive property. When we distribute, that means that we are going to multiply the outside number by, by everything inside of the parentheses. So that's what distributing means. When we see a problem that has parentheses in it, that's what we're going to start with first, every time. Combine like terms is going to be the second step. What we mean by that is we are going to add or subtract the coefficients and slash or the constants. And that's from each other. So I can't subtract a coefficient from a constant, and I can't subtract a constant from a coefficient. I can only do coefficients from coefficients or constants from constants. And then our last step is going to be isolate the variable. And what I mean by that is get the x by itself. That's our whole goal. Just like we were talking about earlier, your whole goal is trying to get that x by itself throughout this entire process. The distributing is going to help make this smaller, and so will the combining like terms. But once we get to this step of isolating the variable, that's when you want to start making zeros and ones by canceling stuff out. So let's use these three steps in the example that's on this side. Okay, here's my example. We have 5 parentheses x minus 2, close parentheses. Minus 2x equals -1. Okay, cool. So first things first, I'm going to start by separating these where that equal sign is so I could show my two different sides. I got this side, and then I got this side. Now, going through those steps that we were just looking at, step number 1 was distribute. So I'm going to multiply the outside number by everything inside of the parentheses. So if I look at this, I see I have my parentheses right here. And my outside number is going to be this 5. And I'm going to multiply that by everything that is inside of these parentheses. I'm not going to do the 2. That's not going to be a part of it because it's outside of the parentheses. I will do each piece that is inside, though. So I'll have this 5 times x and 5 times -2. If you're not sure how to multiply these, you're going to look at that number, the coefficient. I'm adding in this 1 here because every variable has at least a 1 on it. And that's what I'm going to multiply together. I have 5 times 1. Well, I know 5 times 1 is going to be 5. And then I still have that x there too. Okay, now I'm going to do the next part. I have 5 multiplied by -2. Well, that's going to be -10. I still have this -2x. I haven't used it yet. And I still have this -1 because that hasn't been used yet either. All I did here was that first step, which was distributing, multiplying the outside number by everything inside. Okay, cool. So let's try the second step. The second step says combine like terms. I'm going to add or subtract the coefficients and or the constants. So I'm looking at this. When I say like terms, I'm looking for stuff that looks alike. Like I said, we can add coefficients to coefficients or constants to constants. And what I'm seeing here is that I have two variables. So that means that I have two coefficients, and each of those could be added to each other. But when I do this, I want to be careful that I'm looking at the sign that's in front of the number. So that will tell me what I need to do. I have a positive 5x and I have a negative 2. That's telling me that I'm going to subtract these two things from each other because of this negative sign. Think about it as like you're trying to set up a problem with whatever you see. The only pieces I'm using right now are going to be this 5x and this negative 2. So that's why I'm circling them. So you have 5x minus 2x is what I see there. So let's do that. What is 5x minus 2? 5x minus 2, that's going to give me 3x. I haven't used that 10 yet, so I'm still going to write it down. And I haven't used the 1 yet either. So all of those still apply. I just combined my like terms. So now do you see how we made this a little bit smaller from the beginning? I started with this whole long equation, and now I'm down to just this. Now that I've done steps 1 and 2, I'm going to move on to step number 3. Step number 3 says isolate the variable. So that's what I'm going to do. I'm going to get the x by itself. And I said that's when we are going to start using our inverse operations or opposite operations to try and move things around. My job is to get this x by itself. So I want to make sure that that stays there. When I'm doing these, I'm going to undo my adding and subtracting first. When I look at this equation, I see that I have a 10 that's being subtracted from my x. So that's what I'm going to try and get rid of first. The opposite of subtracting is going to be adding. But whatever I do to one side when I'm trying to cancel something out, I got to do to the other. So I have negative 10 plus 10. That is going to end up giving me a 0. I don't have to write the 0, so I'm just going to cross those out, and I'm going to leave 3x behind, and then I'm going to solve the other side. I have negative 1 plus 10. That's going to end up giving me positive 9. And now I still have one more piece that's attached to my x. Again, I want my x to stay and all the other numbers to go. So now that I've done my adding and subtracting, now I want to take care of my multiplying and dividing. So I'm looking at this and I see these two numbers or my number and my letter are right next to each other. That's going to tell me that these are being multiplied together. So I want to use the opposite of multiplication to separate these. Opposite of multiplication is going to be division. So I'm going to divide by 3 on both sides. I'm dividing by 3 because that's the number that I want to get rid of. Again, 3 divided by 3 is going to give me a 1. So I don't need to write in that 1. I could just leave it as x equals 9 divided by 3. That's going to be 3. And now I have my x by itself and I know its value. So when we go through our multi-step equations, sometimes you will use every step and sometimes you won't. Totally fine. In this example, I had to go through all 3 steps that were over here before I could get to my answer. Let's take a look at one that doesn't use all the steps. Let's look at number 1. Here's number 1. I'm going to draw my line down the middle. And this says that we have negative 20 equals 5x plus 5x. First step that we have is going to be distributing. But I can only distribute if I see a set of parentheses. Since I don't see those parentheses, I am not going to do that distributing step. I don't need to. But what I will need to do is use that combining like terms step. So I'm going to move on to that one, number 2. I do see 2 like terms because I see 2 sets of x's in this problem. And remember, when we're trying to combine these, we're going to rely on the signs that are in front of our numbers. So I have a positive 5x plus 5x. This plus sign is telling me that I'm going to be adding these together. So when I put those 2 together, I'm going to end up with 10x on this side. And then I still have a negative 20 over there because I have not touched it yet. And now I'm going to move on to my third step. which is going to be isolating my variable. So I want to get the x by itself. I'm looking at the side that has my x, and I'm noticing that I have a 10 over there. Okay, well, I need to get rid of that 10. Again, when I see a number immediately next to a variable, those are being multiplied together. So to get rid of this 10, I'm going to do the opposite of multiplying, which is dividing by 10. But whatever I do to one side, I have to do to the other. So I have negative 20 divided by 10. That's going to give me negative 2. I still got my equal sign. I do not have my 10s left over because 10 divided by 10 is going to give me 1. But I do have my x still. And that's going to be my answer because I now have my x by itself. I hope this helped a little bit, and I hope you have a great day.